Hello, in this video I'm going to look at the domain of algebraic functions. So by algebraic function I mean, not transcendental functions. So you're just performing algebraic operations like addition, subtraction, multiplication, division, powers, that kind of thing. All right, and this is assuming that you're given an equation, okay? Now I have here a little flow chart because let me kind of summarize this, that essentially your answer is all real, meaning all inputs are valid for the domain, unless there's one of two trouble spots, which is one of them is an even root or radical or division by zero, right? So the idea is you can't divide by zero and you can't take the even root of a positive number. Of a negative number. You can't take the even root of a negative number. So what you're doing is you're checking for both of those and seeing, is that even happening? If it is, then if it's an even root, you want to set the expression under the even root to be greater than or equal to 0 and then solve for what makes that true. If there is a variable in the denominator, you set the denominator, what's in the denominator equal to 0, and then solve for that. And then you exclude those. But essentially, if one of these two trouble spots, I call them trouble spots, if you will. If one of these two, if neither one is in there, then the answer is all real. Everything works, okay? So I just want to address, I think most people understand that, division by 0 isn't possible. I just want to remind you about the even root. And the even root, like if I have something called like x squared equals 4, and I say, what is x? Well, what we do is we take the square root of x squared, right? And we take the square root of 4, take the square root of both sides. And then technically what happens is you're supposed to write the absolute value of x equals 2. And wow, he is really noisy, my cat. And what happens here is to remove the absolute value, you say is that x is equal to plus or minus 2. Because what's happening is before you did all this, you really don't know if x was positive or negative. You don't know. It could have been positive, right? Because a positive 2 squared is 4, and a negative 2 squared is 4. So either one would work. Now, if I tried to say, though, take the square root of, let's say, a negative 4, is that possible? Okay, so like here, when we were solving, we took the square root of 4 and we got 2. Is it possible to take the square root of negative 4? No, because why? If I put a negative number, well, still a negative number squared is 4. And if I use the positive, of course, it's also positive 4. There's no way I can make this positive. So anytime you multiply a number by itself an even number of times, it's always going to be positive. So when you go to take the even root, you can only take the even root of a positive number. You can't take the even root of a negative number. Okay. All right, so now let's go through some examples. So let's say you're asked, find the domain of this kind of long expression here, long polynomial. Well, when I scan it, remember, all I need to do is ask myself, is there an even root? I don't see any, all right? Or is there a variable in the denominator? There's no denominator. So even though we have powers, like here's an even power, but that's not what we're looking for. A root would be a radical or a fractional power. I don't have any of that. Since I don't have any of that, guess what? The answer is all real. And I can just say this, or normally they say this, right? Either one. All right, let's take a look at the next one. So suppose you're given this, right? And you ask yourself, is there an even root? No. Is there a variable in the denominator? Yes, it's right there. So what do I have to do? I have to set the denominator equal to 0 and solve. Because I'm really trying to find out what would make division by 0 occur. And if there is something that would make division by 0 occur, I take it out. I exclude it. So I set t minus 7 equal to 0, and then I solve, and what would make that 0 is if t were 7. If I put 7 in here, 7 minus 7 is 0, and oops, can't do that. So the domain is t cannot be 7 Or you could write it negative infinity to 7 union 7 to infinity, right? So you're taking 7 out. So you're excluding 7. So you're saying everything else is good except 7. All right, let's take a look at this example. Find the domain of the 4th root of 9 minus x. So again, I'm always asking these two questions. Is there an even root or is there a variable in the denominator? In this case, yes, there's an even root. So I have to set everything in the expression that's under the root greater than or equal to 0. So I kind of say, I'm really taking the 4th root of stuff, if you will. And what I have to do, I have to set stuff greater than or equal to 0, whatever's there. So my stuff is 9 minus x. So what I have to make sure is that whatever I'm taking the even root of, which in this case is all of this, that is positive. So what I do is I set that greater than or equal to 0. So I'm saying what makes it positive? What x makes this positive? Now I solve for it. So if I add x to both sides, I get that as long as x is less than or equal to 9, then this expression under the root will be positive. So let's say I choose 9 itself. Well, 9 minus 9 is 0. The 4th root of 0 is 0 because what number multiplied by itself 4 times gives me 0? Well, 0. 0 times 0 times 0 times 0, right? 4 times 0. What if I put in something less than 9, like 8? So 9 minus 8 would be 1, and the fourth root of 1 is 1, so it works. But as soon as I pick a number like bigger than 9, like 10, then 9 minus 10 is negative 1, and I'm taking the 4th root of a negative number, right? So this is my domain. Or I could say from what? In this case, 9 to oops, no, other way around. So sorry. Get that out of the way. Has to be less than 9, right? Oh, that's not working. Sorry, I guess I ran out of tape. So from negative infinity to 9, but I could include 9, right? We saw that 9 works. So anything less than 9, from negative infinity to 9. So that's going to look like this, right? Like that. All right. Now let's take a look at find the domain of this expression or this rational function. And again, we ask, is there an even root? No. But is there a variable in the denominator? Yes. In fact, I've got here k squared and 2k. So I've got to set everything that's in the denominator, right? That's here. Only the denominator, everything in the denominator, equal to 0, and see what makes it so that you do divide by 0. So I say k squared plus 2k minus 15, set it equal to 0. In this case, since it's a second power equation, I'm going to go ahead and factor, right? So k, it's probably 5 and 3, and then plus 5 minus 3. So let's see, plus 5 minus 3 gives me a plus 2. That should work. And this times this is negative 15. All right, so I've got it factored. And so what would make this 0 is if k plus 5 is 0, or if k minus 3 is 0. So in this case, if k is negative 5, or if k is 3, the denominator will be 0. So I don't want those. So I say the domain is that k cannot be negative 5 or 3. So the idea is, by writing it this way, what I'm saying is, as long as k is not negative 5 or 3, k can be anything else. So that's the domain. Or you could write it something like negative infinity to negative 5 union negative 5 to 3 union, that's actually a comma, union 3 to infinity, right? Okay, because what you're saying on a graph is it can't be negative 5 and it can't be 3, right? But it can be everything else, like that. Okay, so now the last example, nope, not last example, maybe, I don't remember, apparently not. Find the domain here of this rational function. And again, you ask yourself two questions. Is there an even root? Is there a variable in the denominator? Well, I see a root, but it's odd. So that's not a problem. You can take the odd roots, right? No problem at all. Still good. But there is a variable in the denominator. So what I have is I have that 1 minus t cannot be 0, right? So if t equals 1, then I got an issue and I divide by 0. So what I have is the domain is t cannot be 1. Or I can say negative infinity to 1, union 1 to infinity, right? But this here doesn't present a problem. This cube root doesn't present a problem at all. Okay, so that would be, if the problem had been written something like this, cube root of t minus 4, it'd be all real. No issues whatsoever. All right, and I think we're on our last one now. So find the domain of this rational function. H of s is 2s minus 3 over s squared plus 1. So variables in the numerator, no problem. It's the denominator. So I want to make sure, I want to see if the denominator could be 0 or not. And therefore I'd be dividing by 0. So I set the denominator equal to 0. So s squared, that's not a 5, it's an s. S squared plus 1 equals 0. So then s squared would be negative 1. But oops, remember, I'm going to take the square root of s squared. I can't take an even root of a negative number right here, right? I can't do it. So what's happening is there is no s for which this denominator is 0. Why? Because no matter what you put in here for s, once you square it, it becomes positive. And a positive number added with 1 will still be positive, so it'll never be 0. And even if I put 0 in here, I'd have 0 plus 1, so I'd be dividing by 1, and that's okay. So here, everything works because there's no issues. So in this case, the domain is all real or negative infinity to positive infinity. All right. So my point in bringing this example up is, even though you go through these two questions, you really do have to understand why you're asking the questions, right? It doesn't matter that there's necessarily a variable in the denominator. There can be a variable in the denominator and there's no division by 0, so there's no issue and you have all real. And that was an example of that, where it's, you know, you'd have that. So just be careful, really understand what's going on behind these questions. But these are the only two issues that you ever have with finding the domain of an algebraic function. And that's it. Thanks so much for listening.